reminder, when's test 2? Okay, it's coming up, isn't it? It's Friday, November 8th, right? This Friday. Yeah, that's when you voted to have it, was this Friday.
No, it was Wednesday because it was on the same day as my.
Oh, okay, okay, I'm sorry. It's Wednesday. I apologize. Well, we'll talk about it anyway and get it out of the way. This gives you a little more time to study. The test is going to start with 4D, as in Delta, which will be the mortgages, credit cards, fixed rate, adjustable rate, loans, all that kind of stuff. There is one, maybe two formulas in there to figure out what the monthly payment will be on a given amount of loan. Okay? But not as many formulas as in section 4A, B, and C. I'll give you the formula, but I will not explain how to use it. It'll just be like last time. It'll just be there. Okay? So the test is going to start with 4D. And let's run it up through, how about 6B? Does that work? Okay, 6B is in Bravo, which is where we are now. So it'll be up through the section that we're doing now, so I'll give you time to do the homework and ask questions and stuff like that. As you are studying for this test, one of the things that you may want to be aware of is, well, first off, where am I on the computer? I'm on Blackboard, right? We're going to come down to the Meta Foundations. There we go. I'm going to go over to My Math Lab over on the left-hand side and click that. Then, aha, have you been to this page before? Does that look familiar? First column, going to click the second option. And let's go to chapter contents. Now, you've had several chapters mentioned that are going to be on this test, for example, 4D. If you just want to study some stuff in 4D, go to the homework in that section. You can go to the book, chapter 4. You can go to Unit D. And then when you go to Unit D, it'll think about for a while. Why isn't it pulling up the rest? Here it is, view the e-text. You'll go to the text. Then within 4D, under the text, wait. In 4D, in the text, it'll have homework problems. Take a look at those homework problems. Some of those homework problems you've already done via the My Math Lab homework. The homework there is problems straight out of the back of the book or straight out of that particular section in the book. Okay? But what's going to wind up happening when I write these tests, I just go to the homework, wherever that might be. Let's try about page right around there. I just go to the homework and look at that, and I'll try to create problems that are similar to that. Or in some cases, 1 or 2 times the test, I'll just pull a problem straight out of the homework, and boom, there it is. Straight out of the homework, right out of the book. Okay. So for the chapter 4 stuff, you can take a look at that. Then, for chapter 5, I go to chapter 5, there is a chapter summary. What this will do is this will include information from 5A, 5B, 5C, all the way up through 5E. And remember, chapter 5 talked about what are ways to collect data. Remember, a convenience sample, a stratified, systematic. We talked about a variety of ways of collecting data. Then we talked about different types of experiments or ways to look at the study. It could either be observational or it could be experimental. We talked about different ways to organize the data with things like histograms and bar graphs and all that kind of stuff. Be sure that you're familiar with all of that. But then with chapter 5, there is a summary, and it goes on for several pages. And it's kind of handy to take a peek at it. Well, go back the other way. And if you take a look at it, okay, it's not bringing it up. Okay, it will bring up the homework for each section. And you can just thumb through the homework for each section, take a look at it, and work some of the problems out of each section. And what I'll wind up doing for the test is I'll just look at the homework and write some that are similar to that, or just take one straight out of the book. And the same thing's true for chapter 6, A and B. Okay, so if you're looking for review stuff, there you go. There's the summary. You've got the MyMathLab homeworks to take a look at. Okay. So I wanted to let you know there are some options there. If you don't want to do this with the e-text, you can always go to the library. They've got copies of the book on reserve in the library, and you can just run with those. Okay. So there's that. All right, so where's that leave us? Well, we were in chapter 6b. In chapter 6b, we were taking a look at variations in data. It's talking about how spread out the data is. It's talking about how do you make some sense of the data. Now, if you'll recall, prior to this, we had started talking about standard deviations. There are two different ways to kind of break the data down. One is with the 5-number summary. There will be one of those 5-number summaries on the test, guaranteed. Then there will be one where I'm going to give you some data and ask you to compute the standard deviation. Now, I wanted to work through a set of data here just to make sure that this stuff makes sense to you. On the test, it's not going to be a huge long string of numbers, 30 or 40 numbers long. It'll be maybe 4 numbers, like what's up there on the board right now. So let's say that, I don't know, you're working Sunday school at church, you're out in the community working with some community group. There's a couple of kids goofing around, they're messing around on their phones, and they found this IQ test. So all of them decided, oh, let's take this IQ test. Let's see who's smart and who isn't. Okay, that's the kind of stuff kids talk about. Okay, and on this test, one of the kids scores 115, one of them scores a 95, one of them scores a 103, and one of them scores an 87. Okay, so they have these scores for their IQ, and the question is, well, are these scores very good? Well, the first thing I ask you is, what is the average, the mean IQ for people? If you took all the IQ scores, line them up, smallest to biggest, where would the average be? And by the average in this case, because it's a bell curve, that could be the mean, the median, or the mode, because all of them are going to be in the same spot. Now, where's the average going to be for an IQ? It should be right about 100. Okay, 100 is average. So is anybody here really in awful shape? No, is anybody really tearing the test up? Yeah. One did okay. Okay? Okay is in above the average. But the question now is, well, how smart am I? Am I the smartest person in the world? I got 115. The next closest was 103. Does that make me really super smart? This is where standard deviation comes into play. This is where some understanding of what it means and how it fits into the bell curve can help you to answer that question of, well, just how smart am I? And then the kiddo that's got the 87, well, does this mean I'm really stupid and everybody's going to hate me and blah, blah, blah? I'm going to have to clean tables at White Castle for the rest of my life? Okay? I was just trying to think of some job. I'm not picking on White Castle or cleaning tables. Those are both very important things, okay? Especially the clean tables. Okay, so how do you do a standard deviation? Well, on Excel, it does it for you. Bing, you just write the code and you're done. But on this test, you're going to have to be able to figure out a standard deviation for a small set of data. I intentionally stopped at the slide where it has all the directions on how to do it. To do the standard deviation, the first thing you do is you compute the mean. So the first step is compute the mean. Well, that means you have to remember, what does mean mean? How's that? Am I getting mean? That means you add them up and divide by what? However many there are, in this case 4. Well, the cool thing about this set of data, I just made it up in the last class and this turned out really cool, so I thought, whoa, I'll just hold on to this. If you add these 4 numbers up, it adds up to 400. Which means that the mean, which is signified as x bar, is going to be the 400 divided by 4, which means that the mean for these kids' grades or scores is 100. Well, that's great. It's right smack dab in the middle where you would expect it to be. And it's an integer value. It's easy to work with. All right. So there's the first step. Step 2 says that for each set of data, you do whatever that value is minus the mean. So what that's going to allow us to do is we're going to take the 115, the 95, the 103, and the 87, and in each case, we're going to subtract whatever the mean is. Well, here the mean's 100. We're going to do the 95 minus the mean. The 103 minus the mean. The 87 minus the mean. Okay, so when you figure these out, this first one's going to be 115 minus 100 is going to give you 15. 95 minus 100 is a negative 5. This is going to be 3. And this is going to be a negative 13. What we've done in this column here is we've done each data point minus the mean. So there's step 2. Now notice that some of these values are negative. Some of the values will always be negative. And if we just added these up, the positives and the negatives are going to kind of cancel each other out, and we're not going to have much left. So to deal with the fact that we have some negatives, the next step is to square each of these. If you square the 15, you get 225. If you square the negative 5, you get a positive 25. And the nice thing is the negative's gone. The bad thing is it keeps putting a line in there. Take the 3 and you square it, you get a 9. Take the negative 13, you square it, you get 169. Okay, so when you add these up, we're going to have 250 plus 178 gives you, when you add them all up, this adds up to be 428. So what we've done is we've done the squares. Then the next thing we did was we added all the squares. That was step 4. Step 4 is pretty quick, isn't it? Really, is any one of these steps hard to do? They're pretty easy, aren't they? The next step is divide by the total number of data points minus 1. Now, we talked about this the other day. The minus 1 is for degrees of freedom. Didn't talk about what that is. There are 2 or 3 things in this. I'm just going to say there they are. The number of data points is 4. So what are we going to divide by? It's going to be divided by 3. So we're going to do the 428 divided by 3. And that gives you 142.667. Okay, so that is step number 5 or number 4 on the list? What's the very last thing to do? Well, we need to undo the squaring. We need the square root. So the very last step is going to be the square root of 142.667. And this works out to be about 11.9. So the standard deviation is about 11.9. This standard deviation will allow you to answer the questions for the kids. How well did I do? Or just how bad is this grade? Or things of that nature. The standard deviation is going to kick in. Okay? Remember we talked some about this screen the other day. That's just the same steps that we just now did. And here's where we divided by 1 less than all of them. And here's where we did our square roots. And I said, hey, what winds up happening is the mean and these standard deviations allow you to fit your data to a normal curve. The normal curve will always have the numbers 68, 95, 99.7. Where those come from involve calculus. We're not going to worry about it. You just need to know 68, 95, 99.7. Okay? That's all you need. It's kind of like we bought Lauren a new car to commute to and from school. All she knows is she test drove the car. We all said, yes, this is reasonable. Came up with a price that we felt was fair on the car. Signed the papers, wrote a check, handed her the key. Now, did Lauren have to do any of the work for the money that was paid for that car? No. Did Lauren have to engineer or build that car? No. All that was done was, here are the keys, sweetheart. And she took it and drove it, and is driving it. The 68, the 95, and the 99.7 are your version of the car keys. How was it built? Don't worry about it. Do you have to work to get it? Nope, don't worry about it. Here they are. Take it, drive it, and have fun with it. Ta-da! Okay? So there is that. Now, how does this work with the data that we have? Well, first thing we do is we come up to this and we say, well, we know that our mean is 100. That's right there in the middle. Then we're going to go one standard deviation this way. I know that the standard deviation was 11.9. Is anybody going to get real upset if I just call it 12? Okay? It'll make the numbers easier. If we go to the right one standard deviation, this is going to be 112. If we go a second standard deviation, it's going to be 124. And any wild guesses what the next number over there is going to be? 136, right? We can also fill in test scores to the left, which will be accomplished not by adding, but by subtracting. So this will be 88, 76, and 64. Still using that 12 from the standard deviation. Okay, now the kiddos came to you and said, well, gosh, how did I do? What's my grade? Did I do well? Did I do poorly? These three numbers, the 68, 95, and 99.7, allow you to figure out how well a particular score, or what the performance was on a particular score. So for example, if the score is between 88 and 112, do you see that you're in this middle area here? And that middle area includes what percent of the population? That's 68%, isn't it? What this means is if you gave this test to 100 people, about 68 of them would get a score between 88 and 112. take a look at the scores that the crew got that we're looking at, that's basically between 88 and 112, isn't it? So everybody there is pretty much in the middle 68%. Now, is that bad or is that normal? That's normal. There are times where you want to be normal. How many of you would want 3 noses on your face? Well, why not? You could breathe better, couldn't you? Yeah, but when I got a runny nose, Chuck, I don't even want to think about it. Okay? You don't want 3 noses because everybody's going to like that, aren't they? Whoa, that's not normal. There are a lot of ways in which you really want to be normal. Ta-da! Basically, these kids all scored in a normal range. If you expand things a little bit, if we go out 2 standard deviations, this would be between 76 and 124. What percent of the population is this going to include? 95%, isn't it? Which is just about everybody. Now, if you've accounted for 95% of the people, what percent is still out there? 5%. Because this bell curve is symmetric, that means half on each side, if you've got 5% to account for, half of it's going to go over here. That's past the 2 standard deviations. That's 2.5%. And the other half's going to go over here. That's another 2.5%. If somebody in that group scored, for example, 128 on their IQ, is that pretty good? That means that they're in maybe the top 2% in the nation. Does that make sense? Now, never took a test, but they suggested Einstein's IQ was probably around a 160. Okay, so if we come out another one, this is going to put us at 148. And then we come out another one, and whoa, look at there, 160. Where's Einstein on this chart? Was he normal as far as IQ goes? No, he wasn't normal in a lot of other ways either. Okay? Sometimes a high IQ does not affect the way you behave and see the world, and other people would never suspect. Other times, everybody pretty well knows. Okay? I hope they're smart, because if they aren't, they're in really big trouble. So he landed way over there. That would be a very, 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 very small percentage of the people, wouldn't it? The point of having standard deviations, the point of having a mean is when you get your data and your standard deviations, you can put your mean right in the middle of this bell curve, and then you can, with your standard deviations, figure out where 68% of the values are, where 95% are, and where 99.7 are. It allows you to quickly identify things that are really unusually big or unusually small. It allows you to identify things that are, yeah, that's normal, I wouldn't worry about that. Does that make sense on how this kind of works? Now, we're not done talking about this. Okay, we're going to come back and we're going to talk some more about it, but I wanted to just kind of lay a basic foundation for you on why standard deviations are even handy, why anybody cares, because it allows you to take any set of data and fit it to this curve. As long as the data is fairly reasonably distributed, a normal distribution, most in the middle and less out on the ends. Now, would a right or a left skew fit well for this? No, it's not a normal distribution. Most things are a normal distribution. This will work well. That's why standard deviations are so popular. because it works for most stuff. Does that make sense to everybody? Hey, what's going to be on your quiz Friday? Oh, that's right. Our test isn't until next Wednesday, so I guess we're stuck with a quiz Friday. Yeah, stuff like this. 6A, 6B, right along in there. 6B, because we did 6A last time, didn't we? So 6B is going to be on your Friday quiz. It'll be things like the 5-number summary, things like computing a standard deviation. I'll give you maybe 4 numbers and ask you to compute it. Be sure that you bring along a calculator. You get to school and you realize, oh crud, I forgot my calculator. What do? Cry. Go to the library, check one out. Folks, I'll see you Friday. I hope you have a good day.